Okay. Thank you so much again. So want to ask from you the questions. So in the past 50 minutes, we learned some things. What are those things? Joseph, what is mole?
Mass of a substance expressed in grams to make.
Wonderful. What is the, how do I know that this is the mass of substance?
Can you repeat that?
How do I know that this is the mass of a substance?
Given its makeup, or like
Google,
its like I'm.
Google.
Like how do you find the mass of a substance? Oh yeah. You Google it. Okay, I understand.
Got it?
Yeah,
So Louis, what is mole?
Oh, mass of a substance expressed in gram makes it 1 mole.
What is 1 mole of sulfuric acid?
How many grams of sulfuric acid?
No, your question should be what is the mass of sulfuric acid?
Well, I said it. What is the mass of the sulfuric acid?
98 AMU.
1 mole of sulfuric acid is 98 AMU.
98 gram.
Grams.
98 gram.
Grams.
Okay, next question is what is the mass of a complicated what is 1 mole of complicated peptide?
What is the mass of the complicated peptide?
1300.
1 mole of complicated peptide is 1300 grams.
Wonderful. So in our lab, we make like in the lab settings, do we make things in kilograms or we make things in grams or we make things in milligrams?
Milligrams?
Yes, we make things in milligrams. So then this mole thing is called in what is the jargon for the mole thing? Like what term do we use for mole in chemistry lab?
millimole.
Scale. We use scale. What we use? Scale. And scale usually means mole, right? And then we say that either it is millimole scale or it is micromole scale. So we have to determine what we want to make and how much do we want to make, right? So that was the thing. Then what is actual yield and what is theoretical yield?
Actual yield is the amount produced by the reaction, and
Yeah,
theoretical yield is what you expect the reaction to produce.
yeah. And is it always 100%?
No, very rarely 100%.
Yeah. So how do we try to make it 100%? Like how do we try to make good close to the 100%?
Add excess
Excess of what?
reactants.
Yeah. So we add excess of reactants, right? And how do we determine the excess of reactants? By experience,
Oh, yeah.
by actually doing the work, we get to know, right? For example, when we do, when we make some recipe at home, right? So we experience something, and then based on that experience, we do the things, right? And those experiences are already written in the scientific literature, right? So if I do experiment, I will write my experience in the paper. Okay, so that is how it is. So these were the fundamental concepts. Now next is very boring thing, which is yesterday I taught you amino acid. Yesterday I taught you amino acid. What is amino acid? What is amino acid? It's simple. Amino acid.
Yes.
Amino group, carboxylic group attached to central carbon makes amino acid.
And then it has different R groups.
They have different R groups. That's it, right? Any confusion? Yeah? No? So let me see that amino acid. Amino acid. This is amino acid, right? This is amino acid. This is amino acid. Got it? So we have amino group, we have carboxylic group, and wherever there is bend, that bend means what? Carbon. That bends mean what? Carbon. C. Got it? So if it is bend, there is a bend here. I will say this is C here. This is C here. This is C here. This is C here. Okay? So C, C C C C C O O H NH2. Got it? So bend means what? A corner means what?
Carbon.
Carbon. All the chemistry. In all chemistry, whenever there is bend, you describe this? Can you describe this now? What is this?
Carbon.
What is this?
Carbon.
What is this?
Carbon.
What is this?
Carbon. Carbon. Carbon.
So how do you say this term?
Carboxylic acid.
Carboxylic acid. And how do you will say this?
Amine.
I mean, both are attached to what?
Carbon.
Carbon. So what this makes? Amino
Amino.
acid. Standard amino acid. Right? Now what is this thing here?
The R group that changes.
R
That
group. You got it, right? You got it. Wonderful. Lois, Kim, did you get it? So here, what is the R group here?
R
Nice.
group.
Yeah, here in this case, what is the R group here? C, 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 C. This is the R group, right? And what this carbon is called? This carbon,
alpha
which
carbon.
is alpha carbon. That is called what?
Alpha carbon.
Alpha carbon. Because and this type of this type of amino acid is called what? Standard amino acid, right? And what is its name?
Leucine.
And
This, right? So let's say if I ask here tyrosine. So this is tyrosine. Where is the alpha carbon here?
Right next to the amine.
This, right? What is the R group here?
the aromatic ring
This one.
with
This one.
OH.
This is the R group here, right? And what is this structure called?
Aromatic ring.
Aromatic ring or benzene. All right? Okay. Now I have to tell you a few things. Tyrosine. So when reaction of two amino acids to form a peptide. Okay, that is here. Okay. Google is making my life easy. Got it? So you have this NH2 group, you have this central alpha carbon, and you have this carboxylic acid group, right? And again, you have this amino acid and this carboxylic acid and this amino group, right? So what happens is that from here, what will get from here, what will we? So NH2 is here, COOH here, right? Got it? You have to focus on it. Uh, I am just saying this is the same thing here. This thing is same here.
Yes.
This is same here, right? And here is NH, NH. Got it? Where is this H gone? I mean, this H went off somewhere because it is not here.
Water.
So this is the same thing here. From here, this thing is same here. Yeah. What is missing here?
Oxygen, hydrogen, alcohol.
This is missing here. OH. Can you see that? So OH and H makes what?
Water.
Water. So this OH is here and this H is here. Got it? And so this bond is called what?
Peptide bond.
Other name of this bond is what?
Covalent.
Amide bond. What?
Amide bond.
Amide bond. If this CONH bond, CONH bond is always called amide bond. But if it is between two amino acids, then we call it peptide bond. Got it? So if this is any other carboxylic group and if it is any other amino group and they make a bond, we will call this bond amide bond. We will call this bond
Amine bond.
amide bond. But if it is between two amino acids, what I will call this?
Peptide bond.
Peptide bond. Now my question is, so this is the story here. This is the story here. You see here, uh, you have NH2 group, NH here, right? You have NH here, and you have carboxylic group here. Do you have carboxylic group here? And you have carboxylic group here. How can I make sure that only this carboxylic acid group react with this amino group?
Protecting groups.
Protecting group. So I have to protect this. I have to
Protect it.
protect this. Got it? So how can I make sure that there are amino acids in which we have extra amino group, right? So if we have extra amino group, we have to protect it. So when we see the, let's say tryptophan, all. So this is the tryptophan, which comes in this form. Let me show you. I mean, I show you what actually I'm going to show you is that I sent you a file, which is this. Uh, I've just sent you a file, which is I think this mass amino acids. I think, yeah. Now we are moving towards the next stage. The next stage is this. Okay. You see, FMOC, LROH. What is this FMOC?
Protecting group.
It is a protecting group, which is protecting the NH2 group. It always protects alpha amino group. It protects what?
Alpha amino group.
Alpha amino group. What I am saying is that, let me see that here. Let me show you here in Google. FMOC tryptophan. You see, this yeah, this is what is this?
Alpha amino group.
Alpha carbon. This is what? Alpha
Mhm.
carbon, right? And what is this? Amino group, right? And this amino group is protected with what?
FMOC.
FMOC. And this is the side chain amino group. This is what?
Side chain.
Side chain amino group. So there are two types of amino group. One which is alpha amino group, another is side chain amino group. So side chain amino group is protected with,
BOC.
and alpha amino group is protected with
FMOC.
FMOC. Very good. Now we have it here. So in all this compound, which group is free?
Carboxylic acid.
Only carboxylic acid, right? And now I have arginine, let's say. Arginine, protect FMOC arginine. Arginine, OH. It's complicated. I don't want to make it complicated. Let me see which structure is not complicated. Okay. This is suitable OH. I want one OH here, something. Okay, 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 yes, fine. If I remove arginine OH, just say that. Okay, I take arginine OH. So this is arginine OH. What we do actually is that, yeah, you see that what in this case, we protect this carboxylic acid group, okay, and we protect this NH2 group, we protect this NH2 group, and we have just this NH here, free. So this free NH will react with the carboxylic group of the second amino acid, right? So what actually I am trying to say, we make sure that only those groups are available for reaction which we want to react. Other groups are always protected. Other groups are always protected. Got it? Is it easy statement what I am saying, Louis? What I am trying to say?
Oh, except the amino group, everything has to be protected.
So that only thing which is available can react with the other thing that way. So in this case, we actually want one carboxylic acid group free and one hydroxyl group free. Got it? Right? So now let's go to the papers, the real papers. The real papers, right? So let's go to the real papers and see what I am trying actually to say. And now there are 2 3 terms that I want you to learn, and then if you learn those terms, then it is very easy for you to understand. Okay. Okay. Where is my seminar? Seminar understanding the no. Okay, maybe I can show you some. No, I want to go for my dissertation proposal. All 2020 dissertation proposal. Okay, yeah, the dissertation proposal. Fine. So I am making you a scientist. Are you happy to become a scientist or you're bored? You will get to know these things later, right? So it's not difficult. So let me show you something. Come, 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 come. I'm sorry, my laptop is troubling. Come. No, please come. Please come. Please come. Please come. Oh, oh, it came. It came. It came. So I will explain all these technical things to you. This is what I want to tell you. This. If you could understand this diagram, you are a peptide chemist. Okay? If you could understand this diagram, you are a peptide chemist. It looks very complicated, but it is very easy if you understand the basics. If you don't understand the basics, you will always struggle. You see, this is a resin. This is what a
Resin.
resin, right? Resin is a solid support. So this is resin, okay? And this is here. Everything is protected. There is no group which is free. This is protected. This is also protected. It has also a PBF. It's not shown here, but it is also protected. This is also protected, and this is also protected. Got it? Now, first step will be if I remove FMOC, what will be exposed here? If I just chop this FMOC, okay, let me do this. I mean, I can do this right now with you. I can remove this FMOC. And if I remove FMOC, what will be there? Sorry. If I remove FMOC, what will be there? Guess.
Free amine.
Free amine. What will be free? Free amine. And in the next amino acid, we will have carboxylic acid group free. Got it? So the next group is like first is 20% piperidine DMF. What is the purpose of 20% piperidine DMF?
Protecting
To deprotect FMOC. To deprotect,
FMO.
it will remove FMOC. This 20% piperidine DMF will remove FMOC. And once it removes FMOC, what will we have?
Free amine.
Free amine. Okay. Then we will add histidine tretyl OH. When we say OH, OH means carboxylic acid group. OH means what?
Carboxylic acid group.
So this carboxylic acid group will react with this free amine, and it will make what? This peptide bond. So we have this group here. So here we have this. If you go here, this is what? Lysine. This is K. This is what? K. Sorry, this is arginine. This is arginine. and this is tryptophan. Okay, and which new bond is formed in this case? Can you tell me?
Which bond?
Yeah, which new bond is formed in this case?
Peptide bond?
No, which? I don't see that. If you see this thing all, can you see this thing all? It is actually inverted here. It is inverted here. It is just flipped. If you flip it, so you can see that this is same until this point. Can you see that? Yeah, it is just flipped. I mean, what I am trying to say, I can show you. Uh, Let me see. Yeah, this one. This thing is same as this thing. Got it? Just flipped. It is just flipped over. And which new bond is here? This is the new bond which is formed. Can you see? It is CONH. Got it? CONH. So it was actually C double bond OOH here, and here it was NH2. So they reacted and this new bond was formed. Got it? So we have tryptophan, we added tryptophan, then again we did what?
I
Deprotection.
have a question.
Yes, sure.
So for the second tryptophan we added, was there no resin on it?
No, no.
Okay.
We just have amino acid, which is
Okay.
FMOC, histidine butyl OH.
Okay.
So we had just carboxylic acid group. And that carboxylic acid group is this, C double bond OOH.
Yep. Got it.
And NH2 is here.
And water is released.
So it is water is released and this new bond is formed. Got it?
Yep.
Now then we did what?
Protecting.
We added
FMOC.
again 20% piperidine DMF.
Deprotected.
So we deprotected this FMOC.
Yep.
And if I deprotected this FMOC, what was present now?
Amine?
Yes, free amine.
Yeah.
Got it? And now this free amine will react with what?
The carboxylic or the alcohol.
Carboxylic acid group of what?
OH.
Arginine. So you see that here. This is the first bond that was formed. And now COONH. And now this was the bond which was formed. So you have to see that. This is arginine. This is tryptophan. After tryptophan is again arginine. This is arginine. Got it? And again tryptophan. Then again arginine. Then again tryptophan. Then again arginine. And then again tryptophan. Got it? So is it clear?
Yep.
Yeah?
Yep.
So we actually do it. We take resin. First we take resin. Then we remove the FMOC from the resin. Okay? And then we react it with the next amino acid. Then we remove the FMOC from the next amino acid, and then we add next amino acid, and we keep on doing this until we get this, until we get this. Then what we do actually, let's make it easy. I remove this resin and I remove all the protecting groups. So what will I get? If I remove from this structure which we have here, this structure, if I remove all the protecting groups and the resin, what will I get?
Arginine.
We will just get peptide.
Yeah. I was gonna like say it out.
Yeah?
I was gonna like say out the
Yeah. The peptide. Okay. So yesterday you were doing cleavage. Final cleavage.
from
Right?
the right.
Yeah. So actually that final cleavage does what? It removes resin and it removes protecting groups.
All at the same time. I was talking.
Yeah, all at the same time. Yes, all at the same time.
I was talking to what's his name? Who were we working with yesterday?
Mm-hmm. Talal.
What was that?
Talal.
Yeah. So he said that it was like half and half or something like that. I was kind of confused. Like
You
you,
Half and half of what?
usually remove everything.
Yeah, it removes everything. The final cleavage removes everything.
yeah, okay,
Final
perfect.
cleavage removes everything. But there is something which is called resin removal only. There
Oh,
is
yeah,
an
no, he was saying, I remember what it was. It was different for the linear versus cyclic peptide.
so now I am just going to tell you this thing. So
Oh, okay.
this is clear. If I want to get the final peptide, I will remove everything.
And that's
All
the
right?
linear one, the linear peptide.
Yeah, so this is the linear peptide. Now, if I
Okay.
want to make a cyclic peptide, if I want to make a
Cyclic peptide.
cyclic peptide, what I do, I don't remove the protecting groups. I do not remove
Protecting groups.
I just remove resin. So if I remove resin, what will I get here?
Carboxylic acid.
Very good. And what we have here?
Amine.
Pre-amine.
So if I react, and if NH2 reacts with this carboxylic acid, because everything is protected, only the two free groups are NH2 and this carboxylic acid group.
Oh, and they can do intermolecular.
Yeah?
Then they do intermolecular reaction with each other.
Yeah. So
To make,
actually this amino group will react with this carboxylic group and it will become cycle.
okay. Oh, wow, that makes a bunch of sense. Thank you.
Got it?
Yep.
And after it becomes cyclic, what we will do, we will then remove the protecting groups.
Okay. But
And
you
then we
want
will get a cyclic peptide.
but you want to keep them protected before you do the intermolecular reaction, or else it might
Yeah,
like that or something like that.
yeah.
Okay. Perfect.
Now we learned two things. One is final cleavage and one is resin cleavage.
hmm
Resin cleavage is done for what?
The resin.
Procyclic
To
peptide.
make the cyclic peptide. And final cleavage is done,
Just finalize the
you just get the peptide.
peptide.
Got it? Is it clear?
Yep.
So let me show you now few schemes from the real papers. Okay, from the real papers. We go to scholar dot sorry. Scholar, and now you will explain me. Scholar.google.com, and I write here TK was Parag. Okay, R4 W4 R4 W4. Okay, this is a real paper, and now you will understand it very quickly, right? Very quickly. This is the fact. This, see what we have here. This is resin. This is what?
Resin.
And this is
Protect.
tryptophan. This is what?
Peptide.
Tryptophan. What is this? Free
Amine.
amino group, right? And I will react this free amino group with FMOC, TRIPOC, OH. What is the meaning of OH?
Hydroxyl group. Carbo.
Carboxylic acid group.
Okay.
OH means?
Carboxylic group.
So this carboxylic acid group will react with amino group to make bond. Then we will remove FMOC. We will remove
F mark.
FMOC. And if we remove FMOC, what we will get? Free amine. Got it? And that free amine will react with the next carboxylic acid group of the next amino acid. Okay, and the chain will grow like this. Then I will do what? I will add this TFE, acetic acid, and DCM. And this thing is just removes the resin. This just removes the
Yes.
resin. And then here we will have carboxylic acid group, and here we will have amino group, and they will react to make this cyclic structure. Okay, and then we will use reagent R, and reagent R is actually the final cleavage. Got it? So yesterday you were using reagent R, which is composed of anisole, thioanisole, DDT, and uh, what was the fourth thing? Yeah, here it is written. Reagent R is anisole, thioanisole, DDT, and TFA. Got it? So, and resin cleavage is TFE, acetic acid, and DCM, where the TFE is 2 times, acetic acid is 1 time, and DCM is 7 times. Okay? So let's wrap up. Let's wrap up. I told you a lot of things today. Like, let's wrap up. What did you learn so far? Just make it easy. Amino acids come in the form of this. Amino acids come in the form of the protecting groups, right? And OH always means what?
Carboxylic.
And N, if there is only N, right? If I say N, FN, arginine, OH, what this N means?
Amine group.
Amino acid. Got it? So this is the jargon. These are the things that you should know. N in peptide chemistry is called amino group, and OH in peptide chemistry is called carboxylic acid group. And this N is always protected with FMOC. Got it? And we can say that FMOC is alpha amino protecting group. Alpha amino
Protecting group.
protecting group. And side chain protecting groups are BOC, TBU, PBF, trityl, trityl, FIFR, OTBU, trityl. These are the side chain protecting groups. Got it? So what is the difference between alpha amino protecting group and side chain protecting group?
It's a different amino group that's getting protected, or the
Yeah, yeah. And carboxylic group is always free. Carboxylic group is always
free.
free. And this carboxylic group actually reacts with what? The amino group of the next amino acid, which is usually protected with FMOC. First, we remove the FMOC and then we react with that.
So every time you add a new amino acid, you're gonna have to remove the protecting group.
Yeah, so now I am telling you what is the procedure. What is the procedure? Overall procedure. Now, these are the terms, these are the jargons you have to know. First, resin swelling. What is resin
Swelling.
swelling? So what actually we do, we take the reaction vessel and we put the resin in it, and then we swell it. Then we will swell it, and we swell it in DMF. We swell it in
DMF.
DMF. How long?
30
Usually for
minutes.
30 minutes. Usually for
30 minutes.
30 minutes. Okay. After resin swelling, we add. Now we have to see whether resin is protected with FMOC or not.
You do the Kaiser test.
No. There is no need for Kaiser test at this moment. We just have to see, and it is written on the bottle. It is written on the bottle whether it is protected or not. If it is protected, what we will do?
Oh, use pipe pyridine to
We will do deprotection. We will do what?
deprotection.
Deprotection. So deprotection means?
Take out the FMOC.
So we'll say means removal of FMOC. Got it? After
What
that, I will do what? Washing.
what is the reagent used for the removal of FMOC?
20% pipe pyridine
20%
with DMF.
pyridine / DMF. Got it? Right? And then washing. Washing is done with DMF. Got it? Why we do washing?
To remove any of like the excess reagents.
Yeah. So in this reaction, if during the we want to remove 20% piperidine, in fact, right? Because if we don't remove 20% piperidine, the next amino acid will not react. Then after washing, what I will do? Coupling. I will do
Coupling.
Coupling means adding next amino acid. Coupling means
Adding mixed amino acid.
adding next amino acid which has free carboxylic acid group. Got it? And this reprotection freed that made NH2 free.
Free.
Got it? Now NH2 is free, carboxylic acid is free, the coupling reaction will happen and the peptide will be formed, right? And always you have to see what is coupling mixture made up of. The coupling mixture is made up of amino acid plus HBTU or HCTU, okay? Then plus DIPEA and then plus DMF. Got it? Then after coupling, you will do what?
Washing.
With what?
DMF.
DMF. After washing, what will you do?
Uh, deep protection.
Deep protection. Very good. Deep protection, right? And after deep protection, you will do what?
Coupling.
Oh,
Washing and then coupling.
washing. And after that, what will you do?
Coupling.
Coupling. Got it? And you keep on doing this, except for this purpose. This is the step you did it once only. And now this I say one. Sorry, no, not one. We will say this one. This we will say two. This we will say sorry two. What? Sorry, what happened? I'm sorry. Are you getting it or no?
Yep. Yep.
Does it make sense more?
Yep.
I mean, now you can come to the lab and you will enjoy more.
I agree. I agree.
Yeah.
Yep.
I mean, previously it was just what they are doing.
Yeah. Just
Now
watch.
you understood why they are doing this.
Hmm.
Can you revise it? Or maybe tomorrow?
Yeah.
No, no, yeah means what? You want to revise it today or tomorrow?
Revise.
Yeah. So whatever I have taught you, I just want to listen from you.
Oh,
We can do it right now.
yeah, I can do
Okay,
it.
do it, do it.
What do we learn in this latest installment of the lecture?
Uh-huh.
So we learned, I guess, the underlying reasons why there's actually coupling and the how you put the amino acids together.
So what is the first step in the peptide synthesis?
Oh, we swallowed the resins for 30 minutes in DMF.
First step is finding a reaction vessel.
Oh, find the reaction vessel and then find the resin.
And then what will you do? After finding the reaction vessel, what will you do?
Find the resin.
Clean the vessel.
Yeah. Yeah.
So you will do what?
Clean.
Clean the vessel. And after cleaning the vessel, what will you do?
Find the resin.
Now, you will mount that reaction vessel on the stand.
Okay.
Got it?
Yep.
And then you will find resin. And then you will weigh resin. And then you will put resin in the reaction vessel. And then you will add DMF. Then you will add
DMF.
DMF to swell it. Okay?
Mhm.
After that, you will do deprotection. And usually you do deprotection for, usually you do it 10 minutes. I don't know why my system is not writing. I don't know what's wrong here. Okay, stop sharing maybe. I mean, I can share again. Share again. Okay. Yeah. Not writing. Why? Okay, I'm sorry. I'm sorry. I'm sorry. It's not writing. Oh, now it started writing. So actually, you do it for 10 minutes, 3 times. Okay? And washing, you do 5 minutes, 3 times. And then coupling, you do usually from 1 hour to 3 hours. Then again washing. Washing is the same. Copy, and I will paste it here. And then deprotection is same. Control C, Control V, and then washing is same, and then coupling is same, and continue. 1, 2, 3, 4, 5, 6, 7. Repeat from 2 to, oh sorry, 2 to 7. Oh,
One.
it should be 2. It should be 3. It should be 4.
Uh,
It should be 5. It should be 6. It should be 7. It should be 8. Repeat from 2 to.
Hey,
Got it?
yep.
Yeah. So now you revise it. What? How will you start? When you come to the lab, you wear the lab coat, and now what you do?
You find your reaction vessel and clean
Then,
it.
then,
After you clean
place it
it,
on the stand.
okay,
The
then,
find the resin.
then,
swell your
Wait,
or
okay,
weigh your resin, weigh your resin.
okay,
then
wait, then,
put it in the vessel,
then,
and then put DMF,
okay, then,
and then swirl it
okay, then,
for 30 minutes.
yeah.
Then
You have to check whether resin was protected or not protected. Okay. If it
Yep.
was protected, you have to do the deprotection.
If it wasn't protected, you don't you skip step 2.
Then you just start with coupling.
Okay, perfect. So you don't
You
have to
just
wash
start with
either.
coupling, right?
No washing either.
No, because
You didn't use
you already swollen it, right?
yeah. Yep.
Yeah. Then,
Yep.
elute out the DMF,
then,
and then put 20% pyridine in DMF,
then.
and then wait for 10 minutes.
Yes, very good. And then,
You repeat that 2 more times,
very good. Then,
and then you elute out the pyridine, 20% pyridine,
okay. Then,
and then you put DMF
mm-hmm,
and wait for 5 minutes.
3 times.
Then you repeat that 2 more times,
Yeah.
and then you elute out the DMF,
Mm-hmm.
and then add, you weigh amino acid
Yeah.
and HBTU, right?
Whatever. I mean, this is called coupling mixture.
Coupling mixture.
This is called what?
Coupling mixture.
Coupling mixture. Okay. So this is a coupling. The coupling mixture has 4 things: amino acid, HCTU, HPTU, DIPA, and DMF. Right. So coupling mixture. Got it? Okay, so you are a peptide chemist now. There is too much to learn. One thing which you have to learn, first of all, you will ask me, sir, or dear scientist, what do you want me to make? How do I do the calculations? Right? How
Yep.
do I do the
Calculate.
calculations? So for calculations, you go to this file, which is this here. I showed you earlier. I don't know where did I show it. I showed it somewhere. Maybe synthesis protocols. I have to search the file. Synthesis protocols. I think you learned today as well something.
Yep.
Okay. Now there is just one technical thing. So this is what. So usually the reason comes with a scale. Reason comes with a scale. It's a new thing I will teach tomorrow, right? So the calculations things I will teach tomorrow, right? How do you do these calculations? And
What
ultimately you do what? You just take the amino acids, weigh them. So you weigh the resin. So this is all weighing. So we do these calculations using this, right? And for this, we just need to know the masses of the amino acids, and we need to know the excess of the amino acids that we want, right? So we'll do that tomorrow because it's too much overwhelming for you. Okay, so uh, I hope you learned something today as well.
Yep.
Is it easy?
Yep. No.
No?
It's making more sense though.
It's difficult?
No, not really, honestly.
I mean, yeah, because this thing is new for you, because this is new. I mean, this is just the first time you're listening to it. But in the lab, we do it every day. So it is like if you work for 7 days, you will be expert in these things,
Exactly.
right? So these are the fundamental concepts. But if I ask someone to come into the lab and he doesn't know mole and he doesn't know chemical reaction and he doesn't know amino acid structure and he doesn't know what is FMOC and he doesn't know what is alpha amino protecting group and what is side chain protecting group and which new bond is formed and what is a coupling mixture, what is deprotection, why do we use 20% pi protein DMF for removing the FMOC, right? So
Yeah.
then he will say, I mean, rest is just cooking. You just mix the things and interestingly, in the automatic peptide synthesizer, we just do what? We put these things in the machines and everything is done automatically and then we get the peptide.
Yeah.
And it is done overnight.
Mhm.
Got it? But there
Yep.
the timings are different. There the timings are different. In this case, like I told you, this is the standard timings. These are the timings that I showed you today in this. So this is to make sure that we don't lose anything, right? But in the PEP machine, uh, we actually don't do it like washing. We do it for 1 minute. Coupling we do it like for 20 minutes or 10 minutes. It is done this much. But I want you to understand this paper, the
Mhm.
paper that I showed you. You can read this paper now. You can learn this paper. And all this thing which I have told you is actually written here. How did you do this? Peptide design and synthesis. You can easily understand this now. This all thing. You can easily understand it. But if you don't know anything basics, you will say it's very complicated. These diagrams look very complicated, but they are not, right? This is arginine, this is arginine, this is tryptophan, this is tryptophan, this is tryptophan. So actually, I see that this is 1, 2, 3, 4 arginine, 1, 2, 3 are tryptophan. All right. What is this? This is a fatty acid. 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 This thing is tryptophan. This thing is arginine. All right. So it becomes this is resin. Okay. Thank you so much. Any questions you have?
What time are we gonna meet tomorrow?
Let's discuss.
I have